Okay, let's talk about ggplot2. Let's jump right in. So objectives are we want to first understand how we're going to construct a basic scatterplot with gg2, and then we'll talk about how to add additional graphics. So let's talk about some basic notes. ggplot2 package must be installed because this is an add-on package, not in the base package. ggplot is the primary function used to initiate a plot. And then the idea is we use other functions to add points to the plot or lines to the plot or titles to the plot. There is some unique syntax associated with ggplot, as we'll see. So let's first talk about building a simple scatter plot. So here is the pseudocode. We're going to run ggplot, and we're going to specify our data frame and specify our mapping. For now, you can just think of this tells us we have this data set, which variables go on the x-axis and which variables go on the y-axis. And then once we know that, we're going to run this function gmPoint with this plus symbol between these two lines of code. And that will construct our basic scatter plot. All right, let's jump in. So first, I've already installed this package, but you would need to install the ggplot2 package. So you're going to need to load the package. And the first thing we always want to do is look at the help file for ggplot. And you'll see ggplot initializes a ggplot object. So the idea when we run ggplot is just to open a window, and then we're going to run more things to actually create the plot as we go. So the things that I recommend running, always specifying in ggplot, are data. So tell it your data set, and mapping. This option is not too informative. The default list of aesthetic mappings used for the plot. But think of this as you at a minimum need to specify your x and y axes, since the data set can have several variables. So it tells us up here that the first pattern is recommended if all layers of the same data, if all layers use the same data and the same aesthetics. So here is the first pattern that I recommend for us until things get more complex. You always want to start with ggplot data is your data frame, and then mapping, tell ggplot what is x and what is I and what is y, and then we can add some other stuff. So first pattern is what we'll focus on. Okay, so as I mentioned, for most plots, you'll specify data frame and mapping in the first line of code so that they are defaulted throughout. So that means if you specify it here, you don't have to keep specifying it later on. So let's jump right in. When I run ggplot data here's my data frame. Here's my mapping. I'm telling it on the x-axis, put text sent. On the y-axis, put text received. And so you can see it did that, but it didn't draw any points yet. I could also just run ggplot. What is this going to do? It's just going to open a blank window. So now we don't have any data sets specified. We don't have anything on the x and y axis. This is just a blank window. Here, I could run this line of code, ggplot. It looks the same, but now I have specified that for the remainder of constructing a plot, I've specified that I'm using the class data. So now let's remember we want to use this basic structure. So let's look at what adding gmPoint does and how does it know to add points specifically for text sent and text received. So let's create our first basic scatter plot. So we're going to run ggplot. I'm going to tell it the data frame, and I'm going to tell it to use text sent for the x-axis and text received for the y-axis. And again, I could type x equals text sent and y equals text received, but I don't have to. And gmPoint says, go add the points wherever I have x. Go add the points for these x's and y's. And because I specified that my data set is this, and my x variable and y variables are these and these, gmPoint knows to go plot text sent by text received. Now, what happens if I run this line of code? I get a bunch of error messages. What happened? So I ran ggplot, but I never told it what are the x variables and what are the y variables. And so when I run point, it tries to find a bunch of different points from a bunch of different variables, and it doesn't know what to do. So what if I tried this approach? ggplot data is class data, gm point, mapping equals AES, text sent, text receive. Then I have my plot was initially constructed, and I'm going to plot. I'm telling R that the point should be the x and the y variables. So this line of code will do the same thing. These two lines of code will do the same thing as these two lines of code. The difference here is up here in ggplot, I've specified always use this for x and this for y unless I say otherwise. Later on, we'll see if I want to add lines and things like that, I would need to re-specify the x and the y variable. So what I'm illustrating is there are lots of ways to construct the original basic scatter plot. I recommend using this way unless there's good reason otherwise. Just to show that what we're doing is can be done using base plot. You'll see if I run attach class data, now I can run plot text sent on the x-axis, text receive on the y-axis, and it gives me the same plot, but it's a lot less fancy. So I had to run attach here since I didn't specify the data set. Okay, moving on. Now we want to talk about how will we change the color, size, shape, and some other options in ggplot. And so the pseudocode looks like this. I'm still going to run ggplot, data is data frame, mapping is, I'm going to specify my x and my y variables, and then gm point, I'm just going to pass different options through gm point. Okay, so let's just generate a plot and see what color, size, shape, alpha, and position do. And before we get too ahead of ourselves, let's see if we can read the gm point help file. So this is a function in R, always a good idea to read it. And here you'll get some intuition on how ggplot2 works. You'll see gm point, it says mapping is null, data is null. It's going to assume that this has already been specified in ggplot, and so it will use the mapping from your previous line of code and the data set from your previous line of code. And so here are some arguments, stat, position, na.rm, show legend, inherit as is, and then a lot of the options in gm point are down here. X, so you can click on alpha, color, fill, group, shape, size, all of these different things are just different ways to plot the points. And so you can read about each of them and how to use them. Let's just show you some examples. Please do read that on your own. Okay, so ggplot, same line of code as before. Now I'm running gm point, but I'm also going to say use red points, change the size to 5, and change alpha to 0.2. And what is alpha? Alpha is this transparency thing where you'll see here I have dark red for 100 and 100, so that means that here you'll see I have light red for text sent 100 and text received about 75. There's only 1 point here, so it gets darker every time we have more and more points. And so this is useful for useful feature for overplotting. So we can see here we have more points where text sent and text received were 100, whereas if you don't specify alpha, then these would all be the same boldness. So alpha 0.2 says I need 5 points to get to maximum boldness. Okay, color, you can imagine, does red, size, uses talks about the size of the circle. So it's always a good idea just to play with some of these different options, read the help file, and see how you specify these different options. But let's see what happens if we change. So we ran the same line of code here, but we were changing color is equal to 2. So If you read the help file, you can see I can use color is equal to 2, 3, 4, 5. Each of those numbers has a different color associated with it. 2 is also red, but now size is 2, so I don't have these big plots. In the help file, you'll also read about position. So another way to avoid overplotting is jitter. What jitter does is it adds or subtracts a small amount in the x and y direction, so that you can see here, if you look carefully at text sent and text received 100, it's a slightly bigger circle because we plotted something that is slightly perturbed for 100 and 100 when there are ties. So it's another way to handle overplotting. What can we do? So using the usual plot function, if we hadn't we ran attached again. Let's run detached. Okay, so let's run attach, and how will we mess with the plotting characters or change the plotting characters using the basic plot function? This is in the PCH file. So if you run help of PCH, you'll see PCH is plotting character, i.e. the symbol to use. So color, background, CEX, this is how you change the size, line width. And here is some different plotting characters. If you say PCH equals 0, it's going to plot a square. The default is 1 for a circle. So all of these different plotting characters that appear to be the default, some of the default for ggplot, some of these out here, but they exist in the base plot package as well. Okay, so it's a matter of specifying one of these options with plot. So let's see what this does. PCH equals 21. Told us this guy, and color equals red, told us red, CEX equals 2, said use slightly larger circles, and background also equals red. So I could do, for example, background equals blue. And you can see the color is the circle around it. Background is the inside of the circle here. So you can mess with plotting characters, all of these different options as well using the base package. Okay, now let's talk about how we would add a line of best fit to using it to a ggplot. So here we have our pseudocode. Assume we've ran everything as before. Now we just need to add this guy, gmsmooth, and again, we have to add a plus at the end of our last line of code. So this is all basically one line of code. You have to have a plus, though, to make sure that R knows it's one line of code. So the common method would be, if you do gmsmooth, method equals lm, that says fit a simple linear model. And we're going to start with standard error equals false because we don't want to get into prediction intervals and things like that just now. So first thing to do is to read the help file. Here's gmsmooth, and again it assumes that we already have default mapping, default data set. So we've specified mapping. We've told R what our x and y variables will be earlier in the line of code. We've told it what the data frame is. And if you read this help file carefully, you'll see method is one of lm, glm, gam, lowS. So these are some functions that you won't learn about until you take a more advanced stat class. So we're going to focus on lm for the moment. You can also specify a formula. You would learn about what these things mean in more advanced stat class. And standard error to display a confidence interval, we're going to set this equal to false to begin with. Okay, so let's start with a new ggplot. So again, I have my data set. I have my mapping that tells R what my x and y variables are. I'm going to add the points using red points, and size is equal to 2. I don't want it to be so big. And alpha is equal to 0.5, so even when there's just 1 point, it'll be kind of dark. And then I'm going to add a line that is a simple linear regression for the line of best fit for a simple linear regression model. No standard error, color is equal to red, and then LTY is equal to 2 is going to tell it a dashed line. And here it is. So you can see I have a line, I have my points. Dashed red line, and let's go through another line of code. What happens here, I'm still using color is equal to red for my points, size is equal to 2, alpha is equal to 0.5. And now I left off the method equals linear model. So now we have this different curvy line. So unfortunately, the default lines that are drawn and the default arguments sometimes used in ggplot are way more advanced than we're capable of learning about. So it does leave us vulnerable to sort of misuse of statistics. And I think we'll see an example of that in a moment. So we don't know what this line is. And so I just wanted to show you that we want to use the simple line until we know more about what's the appropriate line. And so that's why I'm going to recommend that you use a linear model until you know what you're doing. So let's look at this guy. And here's what happens if you use standard error, if you leave off the standard error equals false. So everything is the same. Now I didn't tell it a linear model. Now I didn't tell it to not produce standard error. And so now this is a very nice plot. Unfortunately, without a little bit more advanced stat classes, we don't really know what these are. But for graphical displays, they might be useful. All right, using plot. So here I have the same thing, X. I'm specifying my X and my Y, plotting character and color. And I'm making the points bigger by saying CEX equals 2, and the background is also red, so the outside ring is red, the inside part is red. And now to add a line, I just use AB line linear model, and the generic syntax is Y tilde X. I'm going to tell it that the line should be red and the line type should be 2. So it kind of does the same thing as this first ggplot that we created with the simple linear regression model depicted. Okay. Let's talk about adding titles and labels. So again, let's just jump into the code. I have my data specified. I have my X and Y specified so that I don't have to re-specify them throughout. GM points, I'm going to say, let's do red points, size 5, alpha 0.2. Add my line of best fit, no standard errors, color red, dashed line. And now I can add labels one at a time. So I could say add this title that says texting relationship, plus add a subtitle, student data, sent from Canvas, plus add X label, change that from text sent to sent, and change the Y to received. And here I've kicked up an error message and I'm asking you, or it's not an error message, but here let's go through what happened. It definitely added the texting relationship. It added the subtitle, student data set from Canvas here, but it didn't add this sent and received. You see that it didn't change my X and Y labels. And I left off this plus on purpose to show you the absolutely most common mistake made with ggplot is to leave off this plus. So if there's no plus here, R is going to quit. It's going to submit that line of code. Just to illustrate. That's why that those labels didn't get added. So if we run this again, you'll see that the plot gets generated with these lines of code. And the plot's already pulled up, and when you run labs, you can see how ggplot is inheriting some things. Like it says it knows that X is sent and Y is received, but it didn't add it to the plot. Okay, so what we would do is make sure we don't forget about that plus. And then we have what we want. Okay. Last type of plot, scatter plots across groups. ggplot, so let's just identify the code responsible for plotting the character types and line types. So now I'm going to tell ggplot, again, my data set is the class data. My x-axis, my x variable is text sent, my y variable is text received. But now I'm going to say use color determined by the gender. So I have x is text sent, y is text received, and different color for gender, different shape for gender, and a different line type for gender. So these are all specified in the first line of code, so they will be inherited throughout. And let's see what we get. I'm just changing the size to 2 so I can easily see the points. And I'm going to use not a linear model because in my GM Smooth, remember, I need to specify method equals LM for linear model. I didn't specify it, and so this, I wanted to illustrate a little bit of the dangers of using plotting techniques that are a little bit beyond your statistical grasp. So here's GM point size is equal to 2. What happened here? So let's go through this plot. We have on the x-axis text sent, on the y-axis text received. Now what do you notice? Because I told it different colors for gender, I'm going to have red color for, it tells me over here, females. So whenever I have blue, that's for males. Okay. What about shape? Again, I have different shape for gender. I have circles for females, triangles for males. What about line type? I have a solid line for males, and or a solid line for females, and a dashed line for males. So the nice thing here is this does a lot of difficult plotting with not too much code. All I did was change the point size to 2 instead of 1 on all of these. But what happened was I left out to use a simple linear regression model, which is probably what we would use in this situation where we have a small number of samples. So for each group, we're fitting a linear regression model for just females. We're fitting a linear regression model for just males. We don't have a lot of data to model to fit a complex line for females, and you can see here this M, this is sometimes referred to as overfitting. So this shape is an example of using a bad smoother, or a smoother that is too complex for the data set. So what we should do is, unless we know better, we should use a linear model, unless we have good reason to deviate from it. And all I did was change method equals LM. Okay. Using the plot function, we can do the same thing here. Now it becomes a little extra work. So we still have plot. I've ran attached so that R will find text sent when I say X is equal to text sent. It will find text received when I say Y is text received. And my color is just going to be as.factor of gender. So this as.factor will change gender into a factor that has values 0 or 1 or 2 in this case, and plotting character is gender. So this is not a lot different than what we did before, except for PCH. Now it's actually going to use F for females and M for males. You could change this to numeric as well. We won't get into that here. A B line. Now, I have to know what I'm doing a little bit more to fit this regression line here. So this is saying fit a linear model on text received, but just used females for the Y's, and then just use text sent when gender is equal to females for the X's. So this goes and gets, if you run this line of code by itself, you'll see that it actually gets you a linear model with y-intercept 3.1 and slope 0.95. And so now I'm running a B line. A B line will draw a line with that slope and intercept, and I'm telling it color is 1 and line type is 1. And so there it is. Same thing, except for now I'm saying fit a linear regression model, but just use male data. So I'm looking at text received, but only when gender is equal to male. All right, and I'm telling it color is 2 for red and line type is dashed. And if I wanted to add a legend, I have to do that a little bit manually. Bottom right, inset is equal to 0.1 tells R to move it up inside the plot a little bit. And the legend, I'm going to say concatenate FM, so that will put this F and M here. And I'm telling it to draw a solid line and a dashed line in that order and use color 1 and 2 in that order. Okay, so let's look at multiple scatter plots. So the pseudocode is do everything we just did, but then also have this, use this function, facet wrap, and you have to tell it what factor. So you can construct whatever plot we just did, but then do it for an additional factor if it has multiple levels. So let's just jump in, ggplot. What am I doing here? Telling it the data set, telling it X and Y. I'm telling it just to add points. And now I'm saying create a plot for each value of Pinterest. So I created this plot when Pinterest was no, and then I created a similar plot when Pinterest was equal to Y. And so you see on the top here is no and yes. So it's 2 separate plots. ggplot, let's make it a little bit fancier, just so this was a basic plot, but I can do the same thing here. Telling it, saying here, use the class data, here's X, here's Y, here's my color. Now suppose I want the color to depend on gender, shape to depend on gender, and line type to depend on gender. And then I'm going to change the point size to 2. I'm going to make sure I fit a linear model. And now I'm going to say, do all of this for when Pinterest is no, and do it all again for when Pinterest is yes. And I have to tell it in call is equal to 2. And I'm going to add a label and a title and a subtitle. So here you can see, again, I have gender over here. So let's just look at this left plot. This is exactly the same plot as we made before. I have my blue line and my red line for males and females, which is indicated over here in the legend. I have my plotting characters of triangles and circles indicated over here in the legend. And here is the plot for when Pinterest is no, and here is the same plot, but this time for when Pinterest is yes. Okay. Again, ggplot can do all of the same things that the base plot package can do, but does a lot more sophisticated plotting with a little less work. So make sure you use it carefully and know what you're doing if you're using more complicated statistics.